Next up, Saurabh Gupta, talking about in nanomechanical testing, there's plenty of room at the bottom.
Isn't it incredible that the smartphone thickness has decreased by more than 60% in just over a decade? And it's not just smartphones and consumer electronics. Miniaturization has been occurring in several technological sectors, such as healthcare and renewable energy. This miniaturization revolution has been fueled by our ability to reduce the size of the building block materials to nanoscale. For example, smartphones contain thin films. The thinnest of these are so thin that if I were to stack 10,000 of these on top of each other, the whole stack would be thinner than a sheet of paper. But it's not enough to just be able to make these nanomaterial building blocks. If we want to keep reducing our technological footprint, we need to systematically engineer the mechanical properties of these nanomaterials so that we can go into the future. My research focuses on measuring these mechanical properties. Conventionally, to measure these mechanical properties, you take a block of material, grip it, and pull it apart using a machine like the one on top. But doing this with nanomaterials on such a small scale is not a trivial task. For instance, to tear a sheet of paper, let's say you require 1 Newton of load, or the weight of an apple. Now, if I were to tear a slice of that sheet 1,000 times thinner, then the load required is 1/1,000,000th of the weight of an apple. The conventional machines cannot measure or even apply such small loads. And it is incredibly difficult to handle these nanomaterials, especially when you cannot even see them. I have solved these issues by making a nanoscale version of the conventional mechanical testing machine called a MEMS device. This MEMS device, which is the size of an ant, has human hair-sized mechanical springs and very sensitive electronic sensors which can measure and apply these small loads. And the material is made along with the device, so there's no hassle of handling it. Scaling this device from a lab scale to an industrial scale, where several of these devices can be produced at the same time, can generate large amounts of mechanical data which can support the rapid miniaturization of materials in a systematic manner. I believe very soon we'll be wearing technology and not carrying it, and one day shrink everything to our fingertips because there's still plenty of room at the bottom. Thank you.